Okay, I never lost it.
So what we just talked about in your QOD, when we talked about figuring out the mass of a large molecule, that's what we're going to be talking about today. But we're just going to have sort of a systematic, organized way for you to figure out what the mass is of a larger molecule. So, but let's just start with the basics. So we know a compound is what we've been talking about for a week now. And compounds are just two or more elements that are bonded together to form one molecule. You know, water is a compound. A hydrogen and oxygen bonded together. And when we put a coefficient, so you guys probably know from math, a coefficient, a number that comes, before something. This coefficient, what does it apply to in this example? So 4H2O. What do you think that's actually saying? Beta? 4H2O molecules? Yeah, we're 4 water molecules. Okay? The coefficient in a chemical formula tells you how many molecules of that substance there are. So that 4 tells you there's 4 water molecules. It's written large, it's written same size as your element symbols. The subscripts, those smaller numbers that come below an element, what do those tell you? What are these subscripts? What is this 2, for example, telling you in this chemical symbol? Priscilla?
2 hydrogen.
Yeah, it's telling you how many of a certain atom there are in this element. In this case, 2 hydrogen atoms. So by using these subscripts and coefficients, it just allows us to make our chemical equations and symbols a little bit easier to write. You could write these without coefficients, like this. It's telling you the same thing. We have 4 water molecules, H2O, 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 H2O. Grace?
Couldn't you put H2O in parentheses and then put the 4?
Yeah, you could do it that way. You could also write without a subscript. Okay? Say 4HHOO. There are other ways to show compounds as well, showing the bonds, showing electron dots representing the electrons, showing 3-dimensional models of a compound. We won't get into all of that. You will in high school. But this is what we need to understand for now, what those coefficients and subscripts actually mean. So we're going to start by just saying, okay, let's break down a compound just at first to figure out how many atoms of each element are present. So if I have aluminum oxide, and I want to know how many atoms of each element there are, it's pretty simple. We start by writing out the list of the elements. In aluminum oxide, we have aluminum, we have oxygen. Then we look at the coefficient. What does it mean when there isn't one? Right?
There's only 1.
Yeah, it means 1. So we have 1 molecule of aluminum oxide in this example. And then I figure out how many atoms of each there are. So what's the subscript of aluminum? 2 times the coefficient, which was what? 1. So I have 2 atoms of aluminum total. Oxygen, again, I still have 1 molecule of this compound. What's the number of atoms, Priscilla?
3.
3, for a total of 3 oxygen atoms. Now that may seem like just common sense, because this is a simple example. But we'll get into much more complicated examples in a minute. Because when we're using radicals in our compounds, remember radical is a group of elements that act as sort of one element, like nitrate here. So when we look at this radical, what is this first subscript? What does that apply to? This first three, what's that go with, Jake? Yeah, that just goes with the oxygen. What about the three outside of the parentheses? What does that go with, Grady?
Tells you how many atoms there are.
Not quite atoms.
Or molecules.
Yeah, so tell me how many of these nitrate radicals I have. And I have how many?
3.
3. So this 3 actually goes with the N and it goes with the O. So that's when things become a little bit more complicated. So if we look at this 3 hydrogen carbonate. So first we list the elements. We have hydrogen, carbon, oxygen. How many molecules of this compound are we talking about in this example, Alex? 3. And we're just looking at the coefficient. Bless you. Okay, so how many atoms of hydrogen are there? Joey?
2.
2 is our subscript. So how much hydrogen total? Francesca?
6.
Yeah, there's 6 total atoms of hydrogen in this entire compound. Let's look at carbon. Again, there's 3 molecules of this, so we keep the 3. How about the subscripts of carbon? Grace?
Wait, 3?
Yeah, what is it subscript inside the parentheses?
1.
And outside?
And then
3. So total is 3. For a total of how much carbon?
3. 9.
9 carbon atoms.
So if it doesn't have a coefficient, you assume it's 1.
Yes. No coefficient or no subscript assumes 1. And finally, oxygen. Again, we're talking about 3 molecules. The subscript of oxygen, Aiden?
3. Or 9.
3 inside the parentheses, 3 outside the parentheses, so 9 total. For a grand total of how much oxygen in this? Dean? 27 atoms of oxygen in this. Okay, question, Stephanie?
For the coefficient, it's 3 because there wasn't another one in front of it inside the parentheses, right? So you just assume it's 3.
For which one?
Because you put for the number of molecules, which is the coefficient,
Yes.
it's 3, so you just assume it's 3 since it's not another one?
Yeah, because there's this 3. This 3 goes with all of it.
Oh, okay.
Yeah, it goes with the entire rest of it. That's what the coefficient is. All right, so now we're going to add in our atomic masses here as well. Hello? No, she's not here. Yeah. Okay. So, if we go back here for a second, if I want to then take this one step further and figure out the total mass of this, I just need to multiply how many atoms of hydrogen there are times the mass of hydrogen. How many atoms of carbon there are times the atomic mass of carbon, and add those up, and I can figure out the entire mass of this compound. And that's what we're going to do. Now the first examples are very simple, but we're going to get more complex. So we're going to do this in a chart form here. We're going to condense a little bit. So sodium nitrate. First of all, we have 3 elements here. We have sodium, nitrogen, and oxygen. Getting your periodic table out for the rest of the class. So how many molecules of sodium nitrate do we have here in this example? How many molecules are there? Right?
1.
Just 1. There's no coefficient, so that means 1. We're just going to write a big 1 because it's going to apply to everything. We could have written it 3 separate times. But okay, let's look at the number of atoms Okay, so for sodium, how many atoms of sodium do we have? Just one. How about nitrogen? Dean? So we have a subscript of one molecule, that's one. How about oxygen, Grace?
3.
3. Now I'll use my periodic table. What's the atomic mass of sodium, Carter?
22.989.
Yeah, we could round for these, so let's round them, so 23 we'll say. Nitrogen, what do you guys have for nitrogen? Stephanie?
14.
14. And oxygen, Francesca?
16.
60. Now I multiply the number of atoms of each element times the atomic mass to get the mass of each element. So for sodium, it's just 1 times 23. For nitrogen, it's 1 times 14. For oxygen, there's 3 atoms of oxygen altogether. The mass of one oxygen is 16. So the mass of all of it is 48. Then finally, what is the total mass of all of this then?
85.
I've heard 4 different numbers.
85.
I work on those mental maths. I'll tell Mr. Richards something you guys need to try.
85.
85 cannoli?
85 AU.
85 AMU.
Oh, wait.
And that's how we figure out the total mass of these compounds. HCl, I don't know why I even have this up there. Too simple. Well, 2 elements, hydrogen and chlorine. How many molecules? What are the subscripts? 1, 1. Atomic mass of hydrogen? 1.
Yeah, never mind.
How about chlorine?
35.
35. Multiplied out? 1 and 35. Not an exciting example, is it?
36 AU.
36 AMU.
Oh, I know.
What did you say? Wait till I talk to Mr. Richards.
78.
Carbon dioxide, another simple example. What do we have? 2 elements. Carbon and oxygen. Number of molecules. 1. Number of atoms. 1 and 2. Mass of carbon.
12.
Oxygen.
Oh.
We're trying to remember these?
16.
16. Total mass of carbon.
12.
Total mass of oxygen.
32.
Total mass of molecule. 44 AMU. All right, so now we get to a little bit of a challenge. Stephanie,
How did you know, couldn't that also be chlorine?
gonna be what?
Like, how did you know it was carbon oxide? Like, because couldn't it also be chlorine? Oh, wait, never mind, because they're capital.
Okay. Oh, yes, it's a capital. So yeah, CO, if it were lowercase o, it could be cobalt. That's why we always have a lowercase as the second letter of a symbol. Number of molecules is just a coefficient. So let's I'm gonna start to call on some of you here. All right, so let's start with this larger compound here. Ryan, what elements do we have?
Carbon,
Carbon,
hydrogen,
hydrogen, oxygen. Joey, how many molecules of this do we have?
4.
We have 4. Again, we're looking at the coefficient there. Okay, so what does that mean? How many atoms of carbon is there total, Jake? There's 12, but I want to know total, so include the coefficient. So the subscript is 12.
And then do that times 4. 48.
Yes, there's 48 carbon atoms in this whole molecule. Carter, how about hydrogen? 88. How about oxygen, Aiden? 44. Dean, what's the mass of carbon? A carbon atom?
1 carbon atom, 12 AMU.
12. Hydrogen, Grace? 1. And oxygen, Olivia? 16. Okay, now I'm looking at the mass of all of the carbon. Aiden, what is it?
48.
No. There are 48 atoms of carbon.
Oh, 48.
Each atom has a mass of 12 AMU. Grace? 576
I know the
AMU.
next
Yeah.
one.
Oh, I know the next one.
Where are those mental math skills, Brian?
Yeah, guys.
Okay. 88.
Yes, wow.
So smart, guys.
And how about the oxygen, Joey?
Guys.
600 and no 526.
704. Oh, I'm definitely telling Mr. Richards about that.
I don't have a calculator.
I think you guys might have a quiz this week on mental math.
We have this today.
Can you use your calculator?
No.
Yeah.
Maybe I'll talk to him. Maybe he'll take the
No,
calculator.
no, you're not doing that. No.
All right. Anyway, let's finish up here.
Algebra.
What's the total mass of this whole? Hold on. This whole compound, Alex.
1,368 AMU.
1,368 AMU. So are we understanding how to calculate this?
Yes.
All right, 2 more examples, then you can start. Oh no, then we have a little more notes to do. All right, hydrogen sulfate. So what do we have, Taylor? What elements?
HSO.
HS and O, hydrogen, sulfur, oxygen. How many molecules of this? Grady?
6.
6 total. What's our total number of hydrogen atoms, Joey?
12.
12. How many sulfur atoms, Grace?
32.
No?
Oh, I mean, wait.
I don't think you need a calculator for this one, Grace.
Oh, wait, I'm looking at something different.
It's okay.
Wow. Wow.
I was doing it too much.
Let's walk through our multiplication. What's the subscript for sulfur? What's the coefficient? What is 1 times 6?
I need a calculator.
6.
I'm sorry.
That's all right. No one needs to apologize.
75.
All right, Francesca, how about the oxygen?
24.
24.
I'm the only
No
good
calculator.
one at
Mass of these.
No.
Stephanie, what's the mass of hydrogen?
Yeah.
1.
1. Sulfur, Alex?
32.
32. Priscilla, how about oxygen? 16. Multiply it out. What's the total mass of hydrogen, Carter?
12.
Total mass of sulfur, Jake?
192.
192. And oxygen, Aiden?
Stop touching the card.
384.
384. For a total
Wow.
mass of what? Total mass of this whole raise your hand, please. This whole molecule, Stephanie?
588 AMU.
588 AMU.
Finally.
And I do
All right, let's do this last example. So elements present. Grace, what are our elements? Ni, nickel,
Chlorine.
chlorine, oxygen. Total number of molecules, Joey?
3.
3. Total number of atoms of nickel, Brian? Brian, how about chlorine?
No.
No.
Brian.
Brian.
Because, hold on,
Wait, no, 9.
9. So we have, why 9, Brian?
Because there's a 3 on the outside.
Yes, this 3 on the outside goes in everything inside the parentheses. So it has a subscript of 3 out here, times 3 molecules for 9. And Carter, how about oxygen?
27.
27. 3 times 3 times 3.
On the test, will we be given graphs like this to
Yeah.
do that?
Oh, no, you'll just have to figure it out.
Oh, okay.
All right, mass of nickel. Mass of nickel, D.
59.
59. Chlorine. Francesca?
35.
35. And oxygen, we should know by now. 16.
I looked at them right.
Calculate it out. Total mass of nickel. Jake?
177.
177. Total mass of chlorine. Dean?
315.
315. And oxygen? Francesca? 432. Giving us a grand total for what as the mass of this molecule?
Wait,
Grace?
126.
924 atomic mass units.
For a second, I thought it was particles. But it was like
All right, our last slide here is about metals versus nonmetals. So we've talked about them briefly. Where in the periodic table do you find the metals? Sort of which side, Joey? Yeah, left side of the periodic table are the metals, right side are the nonmetals. We're just going to compare them a bit. When you look at things on the left side of the periodic table, how many electrons do they have in their outer shell? How many valence electrons? Brian?
Like, under 3.
1, 2, or 3. So the metals all have less than 4 electrons in their outer shell. That's what makes them metals. And then nonmetals have more than 4. So what do metals want to do with those electrons? Aiden?
give them away.
Yeah, they're looking to lose those extra electrons. And what are nonmetals looking to do? Grace? Gain electrons to get up to 8. Aiden?
Is that why non-metals and metals usually form?
Yeah, it's why they often form compounds, because they both can accomplish what they're trying to do. So, oxidation numbers of metals are what? Sign. They have extra electrons, so their oxidation numbers are right? Positive. And the nonmetals are missing electrons. Their oxidation numbers are negative. Their general properties are also different. Metals are good conductors, nonmetals are not, of heat and electricity. Metals are malleable. They can be hammered into a shape. They're also ductile. They can be stretched out into a wire. Nonmetals cannot. Nonmetals are brittle. They break. And usually metals and nonmetals will combine to form compounds. And there are some things that are sort of in between. So what do you notice we're missing here? If we say metals have less than 4 electrons and nonmetals have more than 4, what are we missing? No? Dean?
the ones that are exactly.
The ones that have 4 exactly. There are elements that have 4 electrons. Carbon was an example of one of them. And what did we say about them? Their oxidation numbers can be what? positive or negative for. They're sort of in between. They can act as metals or nonmetals. They're called metalloids, some of these things, and we identify them once you draw in this little staircase. The things that straddle this staircase, we call them the metalloids. Okay?
Wait, we draw on our big one? And
Yeah, you could draw it on the little one, that's fine.
Oh, okay.
So what's on this side of that staircase? The left side of the staircase has what? Metals? And then this part on the right, those are the nonmetals. All right, so those are our chemistry notes.